Hello everyone, my name is Vitaly and I am part of Robonomics. Today I'm going to talk to you about trustless physical infrastructure. I'm sure many of you have heard the term DPIN, decentralized physical infrastructure networks. I believe like many buzzwords, it kind of lost its meaning a bit. It just means so many different things to different people. And today specifically, I wanted to go back to the roots. And I think that the value that all of us in Web3 community share is building trustless systems. And the same way we are building trustless systems when we're talking about blockchains, I think we should adapt the same principles when we are talking about physical infrastructure. And what that means for us at Robonomics is that we are building a vertical platform that is trustless on 3 levels. And first and foremost is a Web3 cloud. Sean has given us a great introduction to Polkadot Cloud, and that is exactly the reason why we chose to work with Polkadot. Essentially, Polkadot gives us access to a whole set of cloud services like that AWS or Google Cloud would offer us through Polkadot and its application chains. So for many years already, for example, we work with Crust to store data from all our devices natively within Polkadot. And more recently, we started working with a company called Acurust for compute as well. So within Polkadot, our devices that we connect can request services for compute and storage natively within Polkadot ecosystem. When some other DPIN projects sometimes talk about Web3 Cloud, what that actually means is that the data is stored in AWS or Google Cloud, and then the tokens are just minted separately, and that's what DPIN oftentimes means. Then moving on to the second step is connectivity. We believe it is incredibly important, especially for critical physical systems, to be sensor-proof, so that you can actually always reach your device. We are using primarily peer-to-peer networks to connect our devices. We have adopted libp2p protocol so that it can run on anything from low-level hardware like sensors to something as complicated as robot dogs or humanoid robots. We believe it is incredibly important and something that oftentimes is being missed when devices are connected through centralized gateways. That limits opportunities for you to travel, to deploy new hardware, and actually exposes you to security risks and man-in-the-middle attacks. And last, but definitely not the least, is the physical layer, the device itself. This one is oftentimes missed as well, but we believe that it is incredibly important to have trustless open hardware to be able to claim that your physical system is trustless as well. So throughout the past 10 years that we're working on Robonomics, we have worked with almost anything that moves. Rovers, autonomous boats, drones, industrial arms, for both industrial use cases and also fun ones like painting and cooking waffles. And some more innovative hardware like Boston Dynamics and humanoid robots from Unitree. There we have integrated all of that hardware already, and by default, users can connect this hardware to Polkadot. And all the infrastructure we're running is running on Polkadot, 100%. We have a kind of a unique structure on our parachain that we have almost 2 times more accounts than the token holders. Sometimes it means that the project is kind of getting, people are selling the tokens and basically leaving the accounts empty. But in our case, we actually have more accounts because each account that we connect has its own representation. And we have enabled within Polkadot a subscription mechanism where, for example, if you have a smart home or a smart factory, you can pay a subscription to cloud services through Robonomics. And all the devices that connect through that subscription can send transactions without gas. So even if they have 0 accounts, they can still send transactions. And that's why we have so many accounts, so much more accounts. Almost all of the 5 million string sticks that we've done are actual transactions from the devices themselves. They're not staking rewards or something like that. We actually focus on working with hardware. We have also done 294 proposals on OpenGov, on our chain improvements. And we believe it is very important to build in open as well when you're talking about trustless systems that you're building. So this is just a demonstration that we are building in the open, and we invite everybody to join us. So over the past years, we started working with Polkadot early on, got our slot in Kusama in 2021 as well, and throughout that time, we have built the Web3 cloud and peer-to-peer connectivity layer that allows devices to talk to each other. We consider that at this current stage complete, basically. Obviously, we are very excited about GEM updates and the new evolution. But for now, we have a tested system that we verified that it works. And in 2025 and beyond, we are choosing to focus on the physical layer most. There are many reasons for that, but one of the most important ones is that right now, AIs have learned to understand our world. They can be in our world and interact with the world and do it safely as well. So we are going to see much more autonomous systems around us in daily lives. There are obviously different estimations of how big the market would be. On the higher end, there are up to $24 trillion that will be generated up to 2030 by the introduction of autonomous robotics. This seems like an estimation on the higher end, but when we're thinking about robots that will be able to automate 80% of the manual tasks we do now, this number does not seem unreasonable at all. We are staying ahead of the curve. And 3 months ago, we got a new employee, a humanoid robot named Turbo. That's his Twitter account. So if you want to follow, he lives an active social life. So we invite you to follow his journey. And Turbo is a humanoid robot from Unitree. It is the first company that's selling humanoid robots right now. And we are proud to say that the first money a humanoid robot ever earned was XRT. That happened in January at Consumer Electronics Show, the largest electronics show that happened in Las Vegas. And I wanted to show you how that happened, actually. So people were able to come up to the robot, use Nova Wallet, and pay directly to the robot. The first action that it ever was paid for was a squat, but then it did a lot of handshakes. So once the user sends an account, the robot itself has its own wallet, and it sees that it got paid, and then it executes the mission accordingly and records all the data using decentralized storage systems. So now, as transaction happened, the robot stood up, and then we demonstrate that we've done a ton of interactions with people. The reactions we've seen are amazing. To be honest, I am got much more convinced in the humanoid robot form factor because I believe that, like, based on the reactions I've seen, I think there's just something natural for people to interact with that looks like them. So we are happy to be ahead of the curve and showing and normalizing the interactions with robots in everyday lives. This robot will actually be downstairs the whole evening, so you can actually experience it yourself. If you have a Nova Wallet, you can pay this robot directly for a handshake and interact with it. This is part of our mission to make robots commonplace. We, right now, I would say this robot is kind of 5-year-old baby. It learned how to walk. It can do impressive things, but it cannot do hand manipulation really well. It's pretty clumsy still. So right now, majority of work we do is with researchers who build the new vertical skills for these robots. And the 3 areas that we are working on right now with companies is hospitality and events. That is the easiest one. It's just being cool at the events and talking to people. We have already done a few paid events, and we are bringing this robot to more events in 2025. Another thing that we're working on in construction and maintenance. Surprisingly, we got a lot of demand from these industries, from multiple companies actually, from something easy like going around doing inspections to something really complicated like bricklaying. And last, but definitely not the least, is immobile and elderly care. And here, I wanted to highlight that it is not required always to have an autonomous robot, for example. In the case of elderly care, the robots that are being deployed already are teleoperated remotely. And this already delivers a ton of value when the robot can be 24/7 caring for a person, and the operator can actually maintain a fleet of robots in different people's home and be available 24/7. So we are collaborating with many different companies right now, since we got one of the first who got the robot, and people who train their models for this robot in simulations come to us to actually run time on it and test it on a physical hardware. So one of the examples, we work with a company called Carbon Origins. They are a company that built an autonomy kit for construction equipment. So like a bunch of cameras and an algorithm to make construction equipment autonomous. And the problem they faced is that in about 30 minutes to an hour, their autonomy kit gets dusty and they cannot do autonomy anymore. So the use case we're exploring right now is that the robot would come out instead of a person that's doing it now and just clean the cameras of the autonomy kit. This is something that is relatively easy to implement, and over 3 shifts, it can pay back the use case in 6 to 12 months. And as the robot picks up new skills, we think that it can be doing more general tasks here and there. So like cleaning the autonomy kit, but also bringing the tools, cleaning up, and being the general purpose robot that it is. We are also working very closely with academia. We collaborate with a few university labs on building new skills for humanoid robots, as well as we're bringing this robot to a ton of hackathons as well. Just 2 weeks ago, we brought this robot to Stanford Tree Hacks, the largest hackathon at Stanford, where students got a chance to actually program this robot and build some new use cases for it. And over the past year, we've hosted 6 hackathons in universities and around Bay Area to find out new use cases and actually make this hardware available for people. So we are staying on the cutting edge with hardware that we can buy off the shelf. This robot that I've just showed you is from a company called Unitree. It is a great hardware platform. And we operate this robot with fully open source software. But it also has a proprietary computer that is responsible for some low-level functions that we don't get access to. And even though this robot is under full Robonomics network control, we believe that the fully and truly trustless approach to building physical infrastructure is to build open hardware. Right now, the dominant business model in hardware is to subsidize the cost of hardware itself, because companies are harvesting the data and monetizing the data later. We don't think it's a good model, especially as we are starting to talk about more autonomy in our physical systems, and that just introduces a lot of security risks in our opinion. So we believe that hardware should be as trustless as possible, being open hardware. And for that reason, we are introducing Altruist Sensor. This device over here is an environmental monitoring sensor. It is fully open hardware, and it can measure a lot of different parameters. So this is a schema that, in our opinion at least, is the ideal implementation of a trustless physical infrastructure network that is already operational and working right now. I'm going to go deeper into the details of it and explain it further. So we start with the hardware itself. We believe the hardware should be open and transparent, and you can verify it yourself. So this device can measure temperature, humidity, pressure, pollution, like dust pollution, noise, and also optionally we can measure radiation as well. Viewer discretion advised. I'm going to crack its skull open to show you. So this device has a fully open processor, so it's built on RISC-V. Sean has talked about it as well. We are big supporters of RISC-V architecture as well. So this board has a RISC-V processor in it. Unlike the ARM and x86 processors built by other companies, this processor instruction set is fully open source. And we believe that starting from the first principles, the processor itself should be something you can trust, or don't have to trust, rather. We also publish the designs of the board as well, so you can verify that the placement of all the other components on the board are also correct, and you can make sure that nobody planted something on your board. And obviously, we also run fully open source firmware on this device, and we connect it to Polkadot. So all the cloud services are completely trustless as well. But also, we chose to build a whole service for environmental monitoring. We call it Sensor Network. And there, we open sourced all the infrastructure for running that as well. So you can connect this device directly to Robonomics, pay a subscription, and get to post your devices on Polkadot, record everything, and just enjoy the ease of use. But you can also set up all the servers yourself. Both the IoT cloud provider, so that the signed extrinsics from this device can be batched and published to Polkadot, as well as a sensor connectivity provider that is used to offer real-time data for the map as well. So you can run either on the decentralized infrastructure we provide with Robonomics, or you can actually host it yourself as well. And obviously, we also open source all the user interfaces, the map interface that the device device publishes its data to. And this results in a system that on every level can be verified, is transparent, and you don't have to trust us for that. It is also very flexible. You can use it completely just as a device, plug and play, or you can set it up your own server for your smart city, for example, or some industrial site, and set up your own servers and your own infrastructure interfaces to connect devices to. So imagine if you're just a group of people who have houses around you and want to measure just some metrics only for your community. You can host your own server, store the data on it, so it never actually leaves the premises of your facility, and only store the hashes in Polkadot World Computer. This way, you enjoy the security and the shared security of Polkadot network, while your data still remains within the premises of your site. And Altruist Sensor is available today. Today is the first time you can buy it. So I invite you to check out Altruist Sensor and join the Altruist Collective. This is the, we believe this is the ideal device that to present the trustless system. And we invite you to try it out yourself. But Altruist Sensor is only first device that we are announcing today. We actually are working on a whole line of hardware based on RISC-V processors for your smart home. First and foremost, we are going to release a home server that you can connect your lights, your locks, your plugs, and anything in your home. We already support more than 3,000 devices that you can connect to this home server. And it is also a completely trustless gateway to your home, essentially, that by connecting it to Robonomics, you can use your wallet key essentially as a key to your home. Another device that is pretty interesting is an energy monitor that is non-invasive. You can attach it to your electrical box and measure the electricity consumption. We also don't require you to connect it to the cloud. It has local updates, a feature that none of the other electricity monitors have. And the last device we've already announced is Smart Tamagotchi. This is a pretty interesting device because it doesn't have a one use case. It's a developer board. So you can integrate it with any of your applications and have a physical device that can trigger things on your application in Web3. So this device can sign extrinsics, and we already sold the first batch to Gear protocol. They are going to use this in their educational course where people could actually use a physical device to sign transactions. And this developer board I just talked about also will become the foundation of the leasing chip that we want to present. Do any of you know where the term smart contract actually was first mentioned? Have you heard?
Oh, it was like a
Nick Szabo's paper.
Blog. Yeah.
Yes, exactly. And there he gave two examples: a vending machine operated by a community, and a car lease, where if you stop paying your car lease, the lock of your car actually stops working next time you want to drive. So that paper was published in 1997, and
I remember it well.
yay! With this leasing chip, we can actually go down to the hardware level and guarantee the same use case on the physical level. And cryptographically prove that, for example, if payment does not happen, the device would not go on and proceed to deliver the service. Or if it does, then we can verify complete digital twin of the device that's signed by this chip and make sure that the service was actually delivered accordingly to what you requested. With this, we are exploring now the last frontier, basically. We are thinking of an entity that can fully be comprised of autonomous entities. So we believe that autonomous systems be everywhere around us, and companies essentially be fully comprised of these autonomous entities, where only people will only be doing governance. So we already financed a few installations of both industrial robots, innovative hardware like humanoid robots, as well as some operating capital to manufacture hardware. Before I mentioned that the market size for automation in the next 5 years is going to be $24 trillion. These money should be financed. Most of the hardware that's being installed actually is financed. So we believe that by utilizing Web3 governance instruments, we can actually come up with a new type of company where workers are only autonomous systems and where we use governance instruments and maybe even prediction markets to make decisions of which hardware is going to perform better and how to make decisions on which hardware to support and manufacture. So this is what I wanted to share today. We are working with anything from simple sensors to really cutting-edge hardware like humanoid robots, and we are shaping the future of the physical world. So I would love to answer any questions, and thank you so much. Yeah.
Is there a secure enclave in all these chips? Like, how does key storage work?
So no, not on this particular chip. We don't see it as a wallet per se. So for now, we just do a normal chip and computation. We can have a secure enclave on RISC-V chips. It's pretty new. We don't start with that, but I believe that's where we will come when we are actually going to manufacture the leasing chip.
How much more do you think that costs? Adds the cost?
It's a good question. I don't really have an answer for it right now, but I think that given that the board itself is not as expensive, and when we are implementing that as a leasing chip for actual financing use cases, this won't be like basically negligible cost for the cost of the whole automation project. Like if we're talking about smart factory installing even 10 robot arms, the cost of the leasing chip is negligible to that, and the cost of the secure enclave in that is also going to be negligible. It's, yeah. Thank you so much. And Turbo, our robot, is downstairs. So it's going to be here the whole evening. So come join the Nova party and experience the future yourself.